Let's take a look at how we solve rational equations. We got to start on this last week. This is just going to be a little bit more. So we did look at some rational equations last week, and this week we're just going to look at them again, make sure we really understand how to solve them. If you'll recall last week, we looked at two things. The first thing we did was look at the domain. And we said, hey, there's probably some restrictions in the domain because we don't want a value that's going to make our denominator 0. So I don't want x minus 1 to be 0. So I don't want x to be 1. And I don't want x plus 1 to be 0. So x can't be negative 1. So there's our restrictions. The other thing we looked at was the least common denominator. And the least common denominator is what the denominator would be if I were to go through all of the work to make them the same denominator. And in this case, that would be x plus 1, x minus 1. And again, that's not, rocket science. That was just looking at what the denominators were. I had the x plus 1 in common, so I didn't have to write it twice because it was already there. So that would be my denominator. And what am I going to do with that? Well, I'm going to take my original equation, just as it is. I'm going to rewrite it, and I'm just leaving just a lot of space on the top because I'm going to end up, x plus 1, I'm going to end up doing some crossing off. Now, some people just are able to do it without writing both factors, which you will get to that point if you're not there already. If you are, that's fine. Just make sure you notate that that's what you're doing, is multiplying everything by x plus 1, x minus 1 when you're showing work, because that's important. And the whole purpose, of course, in doing that was that I can do some simplification and see what's left. So now I'm just going to write what's left. And here I have 1 times x plus 1, which is just x plus 1. I have a minus 2x being multiplied by x minus 1. I'm going to keep that in the parentheses so that I remember to distribute the minus 2x. And I have a positive 2 multiplied by the quantity of x minus 1. Again, I could have distributed on this step, but it's a good idea to try not to do too many things at one time. Now I'm going to simplify a little bit. I have x plus 1 minus 2x squared plus 2x. And here I have 2x minus 2. I really want to simplify a little bit more before I get everything to one side. So I'm going to simplify the x with the x. That gives me negative 2x squared plus 3x plus 1 equals 2x minus 2. Get everything to one side or the other. I'm going to choose to move everything to the right just because I want my 2x to be positive. So I'm going to add 2x squared to each side, which gets rid of it on this side and puts a positive 2x squared on the right. I'm going to subtract 3x, so 2x minus 3x is going to give me negative 1x. Then I'm going to subtract 1, which gives me minus 3. Now, keep in mind this is set equal to 0, which means from here I want to be able to factor. So, using my amazing factoring, a times c would be 2 times negative 3, which is negative 6. I want numbers that multiply to negative 6, that subtract or have a difference of negative 1. So it seems like 2 and negative 3 are the way to go. So what does that tell me to do? That says take x plus 2 divided by a and x minus 3 divided by a being the 2. Reduce if possible, so 2 over 2 obviously reduces to 1. And 3 over 2 doesn't reduce nicely, so we take that 2 and pop it out front, so 2x minus 3. Now I have factored completely, and I need to solve. So to solve, I'm going to take x plus 1, set it equal to 0 to get x is negative 1. And I'm going to take 2x minus 3, set it equal to 0. So 2x is 3, x is 3 halves. So I could say that my two solutions are negative 1 and 3 halves, But when we get done with this, we always look back up here. We always look at any restrictions on our domain, and it says very specifically, x cannot be -1, so that is not a solution. 3/2 is the only solution to this rational equation. So let's take a look at this question together. And this one can get really complicated, so I'll do my best to make it make sense. Sorry if I fail. So first of all, we're dealing with a distance equals rate times time question, because we've got distances and rates and times and all sorts of stuff going on in this question. And what we want to do is we know some information. So we see 60 kilometers twice, that's distance, and I'm going to use two different colors here. So I'm going to use with the current to be green, and I'm going to use against the current to be blue. So what I know about with the current is 60 kilometers with the current, and I know also 60 kilometers against the current. So that is a distance for both of them. Now keep in mind, I'll have a rate and I'll have a time for both of them. Well, what I'm looking for my solution is determine the speed of the fishing boat in still water, which is not with or against, it's going to be involved in both. So I'm just going to call that R, because obviously it's a rate. And what else do I know? Well, I'm going to have to break out a new color, because I know that 2.5 kilometers per hour is actually a rate. Let's just use red again. So this is related to the rate, because it's either adding. If I'm going with the current, it's going to be pushing my cute little fishing boat along, and if it's going against the current, it's going to be hindering me and making me go slower. So what else do I know? I know that the time with the current is 2 hours less time than against the current. So let's just take a look at this yellow one for a minute and see if we can set up a relation between those two. We want to see how they're related to one another. So I know that the time with the current, I can do that in 2 hours less time. So I'd have to add 2 hours to that time with the current to make it equal to the time against the current. Hopefully that makes sense. So why did I do it that way? And I'm not using variables yet, because it just makes sense to determine how are the two times related. So now let's look at how the rates are related. So let's get the red pen back out. Now I'm looking at rates. What do I know about rate? And I'm going to say with current and against current. Well, if I am with the current, my rate is R, because that's the speed of my boat, but with the current means that current is helping me go faster. So that's great. I guess I should have used green and blue. Sorry about that. I'll circle it in green. You're welcome. Against the current, I'm still going R speed in my boat, but I'm actually feeling like I'm going not quite as fast, because I am going against the current and it's making me go slower. So now I have with the current against the current, and that's a rate, and here's my distance. Whoops, I thought I was still green. Here's my distance and here's my rate for with. Do I know a time? Well, no, because I'm trying to solve for time, right? That's the question, or that's what I've got going on over here anyway. So what I'm going to do is I'm going to take my D equals RT, and I'm going to say, well, I really want that to be time. I want it to be time equals. So if I take each side divided by R, that gives me T equals distance divided by rate. So this is going to be T equals the distance of 60 divided by the rate of R plus 2.5. And this one is going to be the time against the current is the distance of 60 over here divided by the rate of r minus 2.5. So why did I go to all of that trouble? Because this is my time against the current, and this is my time with the current. So all of that work just to make a stinking equation, but now we know how to solve this equation because it's a rational equation. So quickly, let's chat about the domain. How would I restrict it? Well, I don't want r plus 2.5 to be equal to 0, so r cannot be negative 2.5. And it can't be anyway, right, because it's a rate. And then r minus 2.5 can't be 0, so r cannot be positive 2.5, or really anything negative. So let's solve. To solve this, remember I'm looking for the least common denominator. I'm going to multiply everything by that. So I'm going to show a little less work this time. I'm just going to put a big fat r plus 2.5, r minus 2.5, and I'm just going to be doing the crossing off in my head. So in the first one, the r plus 2.5 would cross off, and I'd be left with 60 that I already had, and then the r minus 2.5 that didn't cross off. The 2 actually gets multiplied by both because there's nothing to cross off. No fun reductions on that one. And the last one, the r minus 2.5 would cross off, and I'd be left with 60, and then r plus 2.5. So obviously I still have a lot of work to do because I've got some distributive property and whatnot. So 60r minus 150 plus 2r. Oops, I'm actually going to FOIL this. R squared minus 2.5r plus 2.5r. Those go away. Minus 6.25 equals 60r plus 150. And now I'm going to distribute the 2. So 2r squared minus 12.5 equals 60r plus 150. And I'm actually just going to do this because I've got a 60r on each side, so let's just get rid of it. And what do I have left on the left side? I've got 2r squared. I've got a minus 250 and a minus 12.5, so that's minus 162.5. On the right side I have 150. So I either want to get everything to the right or everything to the left, or maybe I want to split them up. And if you'll notice, because I was able to cross off these 60 r's, I don't have a middle value, a b value anymore. So it just makes sense for me to actually split them and solve using the square root property. So if I add 162.5 to each side, I get 312.5. Divide each side by 2, I get 156.25. And now I'm dealing with something where I just have to use my calculator to take the square root. So I get r equals plus or minus 12.5 rounded to the nearest tenth. And actually I didn't have to round. And of course I know that because r is a rate, then I'm dealing with the positive value only. So my sentence would read that the speed of the boat in still water is 12.5 kilometers per hour. Sorry that last question took so long, but here's one more for you to try on your own. So try this question, then press play and see how you did. So this one is similar to the ones we did before. The only difference here is I would really have to factor this first, and this happens to factor into x minus 5, x plus 1, which works out really well because then my LCD is x minus 5, x plus 1. My restricted domain would be that x minus 5 can't equal to 0. So x is 5, or x can't be 5. X plus 1 cannot be 0, so x can't be negative 1. Make sure you check those at the end once we're done. I'm going to take everything times the least common denominator. Again, I'm going to show a little bit less work just for the sake of time because this is already a long video. So I'm going to take everything times that. On the first one, that's going to cross off the x plus 5 and leave me with 3x and then x plus 1. On the second one, the x plus 1 will cancel, leaving me with 2 and x minus 5. And on my last fraction, both of those would cancel, leaving me with just 2x squared plus 40. And now I'm going to simplify, use that distributive property as much as possible. 3x squared plus 3x equals 2x minus 10. Everything else gets recopied. Now let's get everything to one side because this is a quadratic after all, and I've got a b value in the middle, so I can't separate my values. So I'm going to subtract 2x from each side, which 3x squared minus 2x squared from each side. So if I subtract them, I get x squared. I'm going to subtract 2x from each side, so 3x minus 2x is just x. And then I actually have to, add the 10 and subtract the 40, or combine those together to make 30, which I would then subtract from each side. So minus 30 equals 0. Then this one turns out to be not so bad because this is easily factorable. Numbers that multiply to 30 with a difference of 1 are 5 and 6. I want the 6, I want it to be, oops, that should be a plus, I'm sorry. When I subtracted 2x, I should get positive 1x. So this should be x plus 6, x minus 5, which means x is equal to negative 6, and x is equal to positive 5 if I set each of those equal to 0. But if I look back up here, I notice that 5 is not a solution that I can have, so my final answer is x equals negative 6.